Well, before you get too far into quadratic relations, one thing you need to figure out about parabolas is what all their parts are. The easiest part to find out about a parabola is its vertex. So this is the vertex right here, and the vertex simply is the lowest point in an upward facing parabola, or the highest point in a downward facing parabola. In a down facing parabola. So for instance, in this particular parabola facing up, it's the lowest point. In this particular one, it faces down, the vertex is the highest point. So we just look at it, here's the highest point, that's the vertex. There's actually another name for these particular things, other than vertex. In this upward facing one, this vertex, well, there's a piece of it is called the minimum. And all the minimum is the lowest y value in an upward facing parabola. So since this one faces upward, its minimum is the lowest y value. So let's say that this particular point here is 0, 1. The minimum will be 1. So minimum equals 1. Now in this particular parabola that faces upwards, is there a maximum? Well, as I've said before, these little arrows at the top here mean that it goes on forever. So there is no maximum. It will go on to infinity. In a downward facing parabola, it will go downwards in infinity, so there is no minimum. So you can probably guess what it will have is a maximum. And a maximum, quite simply, is the highest y value in a down-facing parabola. In a down-facing parabola. So quite simply, if this is 0.1, -1, then the maximum will be the highest y value. So the max equals -1. And that's it. Vertex, minimum, and maximum. Now there are actually a few other parts of a parabola. You cannot see them on both of these parabolas, but let's actually draw a new parabola here. We have vertex, we have maximum, we have minimum, and finally we have something called intercepts. Now, if you are playing football and someone throws a pass and it's not meant for you, but you catch it anyways, you have intercepted the ball. You have gotten in the way. Well, an intercept is kind of the same thing in a parabola. Pretty similar idea. So here's my parabola. And remember that this is the y-axis and this is the x-axis. Quite simply, there are two types of intercepts. There are y-intercepts and there are x-intercepts. Can you guess where the y-intercepts are? Quite simply, the y-intercept is where the parabola intercepts the y-axis. So right here. So the y-intercept there will be the y value where the parabola meets or intercepts the y-axis. So if this is 0.0, -1, then the y-intercept is -1. The x-intercepts, as you can probably guess, are the x values, because there are often to the x values where the parabola meets the x-axis. Now, this particular parabola meets the x-axis in two places, here and here. So if this is point 3, 0, and this is point -2, 0, then the x-intercepts equal -2 and 3. Simple enough. Some parabolas will not have a x-intercept. So for instance, this parabola, its maximum is right here. It does not get high enough to touch the x-axis, so there are, as you can see here, no x-intercepts. This one has 2. You will always have 0 or 2. You can never have 1. The only time you will have one x-intercept is when the parabola's maximum or minimum, or its vertex, is exactly on the x-axis. So I shouldn't say never, but the only time you have one x-intercept is when the vertex is on the x-axis. So in this case, the x-intercept would be 0. You will always, always, always have a y-intercept. Well, you might be saying, well, what about this particular parabola? It doesn't look like it's going to hit y. Well, once the values get big enough, it will. It will eventually hit y. It may not hit y for a long time. It might not hit y until we get very, 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 very close to 0. But it's going to hit y. So there's always going to be a y-intercept on a quadratic relation. So that's it. You've got vertex, maximums, minimums, x-intercepts, and y-intercepts. Those are the main parts of a parabola.